What is up, everybody? A morning stream today. I was thinking about doing something, cool. So here we are with something I love the most, machine learning. If you can see, I have this tab open with a Google Colab notebook. I'll try and make it available in the comments or description. It's a weather data prediction. So we also have a weather.csv file, which is my raw data. It's a basic, it's not a project, it's just a look into linear regression. So I have a CSV file here. Here I have a CSV file, right? With multiple 3000 entries and everything. And well, this is probably, as I will do it, I think it's a linear regression problem, right? Uh, so let me just set up the context. Start a bit about linear regression first. What is linear regression? Why linear regression? And what all the benefits are and everything. Uh, Let me just, if we can, we can set up the calendar. Also, I'm not streaming during my consistent times. Like I'm trying to, mix it up a bit. Check, check with the times and check with the, content type of content I'm sharing. I'm starting to share actually. Just give me a second. Just give me a second, guys. Yeah, this is it. I'm just checking the visibility of that product over for second beforehand. Okay, yeah, just give me a second. Yeah, so I was with linear again. So let me just give you a mild example. Then. Suppose you are at a shop, okay, street side shop that is selling, yeah, I know what that is selling. That is selling, uh, let's say, it's selling Thanda mango shake, right? So you're standing, this is you, right? You see, and this is the place with the mango shake, right? Okay. So this is some place that sells killer mango shake, and you go there every day, and you try that. So one day you think, why not? Let's check how many mango shake this place sells, right? So you start maintaining a diary. You start maintaining a diary, right? What you write in the diary, the mango shakes, and the temperature of the day. So obviously it's summer, so you write the, yeah, it's the day. The day is Monday. It's 100 mango shakes sold. It was 40 degrees or 30 degrees. It's squeeze was 35 degrees, and the 12 mango shakes sold. And suppose goodness there was, I mean, it rained or something, so it was 25 degrees, so 80 sold. And you then plot those, right? You plot the mango shakes across the temp, and you get something like this. Okay. You get something like this, like this is for Monday, then Tuesday. You get this for Monday, and Tuesday. Probably Wednesday, Thursday somewhere here. Friday you get something like this. Saturday maybe this one. So like this you have maybe Sunday no mango shake is sold, or because very less temperature, no mango shake is very less amount of. So you can see if I zoom in onto this, you can see carefully zoom in onto this. Yeah. Uh, so it's almost a straight line, right? Like it's it's a general you get the general idea, like it's a straight line. Like the temperature increases, the sales of mango shake increase, sales of mango shake increase. Because the hotter it is, the more people want mango shake. Right. Okay. So, but what happens now? You have this finding, you tell the shopkeeper, and he asks you a question, right? Okay, according to the weather team, weather forecast I have seen on my phone in Google in weather app, I see that tomorrow will be 34 degrees. So can you just tell me how many mango shakes I will sell so that I will prepare that amount of mango shakes and I will have no wastage or I will have no shortage. So this is where so you cannot give him an exact general idea since it's not an exact straight line. It's not exact directly proportional and it's just an idea. So this is where the point of linear regression comes in. So so what we have here is some data. This is our past data, and we're trying to predict a future point or a future data. Like, and how we bridge the gap? We bridge the gap using something very interesting, something the most basic of ML algos, which is linear regression. Linear regression. So if you look around, and let me just go to wiki. Give me a second. Let me just go to just give me a second. Sorry about that. Yeah, so where were we? We were trying, no, it was to just get the definition of linear regression. Uh, okay, this one will work. This one definition. If you can see it, I'll remove this. Let me see if it's visible. Yeah, it's visible. Yes. So it's a statistical method. It's a statistical method used to model the relationship between a dependent variable and one or more independent variables by fitting a linear equation to the observed data. So we need to observe data, we need to, and it's used to model a relationship, right? So what is a dependent variable and an independent variable, right? You know what a variable is. So here we just go back to this. So we now learn two things. Something is variable and it's dependent on independent. Let me just open the chat just in case somebody. I don't see anybody. And this YouTube verification actually like making my life hell. So speaking of dependent variables, so we were speaking of dependent and independent variables. So if we graph it out, you see in this example we're speaking of, in this example of this case, here's the temperature and here's the mango shake. So the number of mango shakes sold depends on temperature. Like if temperature is more, mango shakes will be more. But temperature doesn't depend on mango shake. It's independent. Like each day will have a particular temperature, right? Each day will have a particular highest temperature. It doesn't depend on. Have you ever seen something like this happen? That yeah, multiple mango shakes have been sold today, so temperature has to turn high. So that doesn't happen, right? The thing that happens is when temperature is already high, number of mango shakes is increasing. So in this case, this mango shake is the dependent variable, temperature is the independent variable, and using past data, we have to figure out a relationship. We have to figure out a relationship between these two. How? By trying to fit, by trying to fit a linear, not linear, by trying to fit a line. And this line is called the regression line. So let's get our hands dirty. Let's go into. a bit of. Let me just tell you the use cases, right? Some use cases might be if a hospital has a record of the age, blood group, blood sugar, workout history, like this. They can uh, have it plotted out. This can be independent variables, right? Independent variables. And the dependent variable can be like chances of a heart attack, or not chances. Let's say if they have this like optimum heart rate at your age with this blood group. So this will be dependent variable they can calculate, right? If your heart rate is lower or if your heart rate is higher, then they can administer proper medicine and everything. Or suppose you are a real estate agent, you have real estate agent, you have the location, the neighborhood details, the area, I mean area in square feet of a plot, number of rooms of a house, like a number of rooms, it's a 2 BHK, it's a 3 BHK, which floor it is in, since first floor, ground, or like third floor. You can determine this if these are independent variables. The dependent variables you can determine like the price of the house, and at that point you can start negotiating. You know, so these are some real life use cases. Let's get into a bit of technicalities. Um, so if we find a line that fits the data, like not exactly over the data, that might cause overfitting. Something that closely caters to the data. Is this the data? These are the data points. Okay. We find some line that is, you know, this can be a line, this can be a line, this can be a line, this can be a line. So it's very clearly evident that this line is the best fit for the data, like line of best fit. So it's called line of best fit, or what it's else is called regression line. So how to find it? Like these are all talks. We actually have to find it by maths. Don't worry, while coding, we don't have to do the actual maths. Computer takes care of it for us. But exactly how? And also, why is it best fit? Like it isn't fitting everything. So we have this concept, like loss. So the least amount of loss will be the best structure for predicting. So the loss we generally use during linear regression is RMSE or MSE, which refers to mean square error or root mean square error, right? Mean square error or root mean square error. So basically, we draw this line, which are the predicted points, and this is the predicted points. And this amount of line we call it. So if the predicted point is yi hat, and the actual point is yi, we take the square, right? Then we take the mean of the square if there from summation I equal to 1 to n. So there are n number of particles. And in root mean square error, we take the root of this, right? Like this. We take the summation 1 to n, I equal to 1 to n. In root mean square error, we just take this, right? So to reduce this, we tell if we can reduce this, the line is best fit. Mathematically, let's between y and x, right? So it's like a straight line, y equal to mx plus b. So these are the values that are the trainable parameters, right? The model has to train something. These are the trainable parameters. The model trains the data and learns these, and then finds out y hat based on the error, and we get y and you know m and v, the slope and intercept, and intercept. So this is a vector, right? Y is a vector, x is a vector, slope and intercept. Generally, m and b's are also vectors. Right? Uh, so that's how we get the slope, intercept, and then we predict like we predict that y is equal to we have some vector x, and this is what we got as the introduction. So for data initially, so today I'm planning to do first we are planning to do with the classification. We have the data. We'll first take insights into the data. So since all this is not generally the first step, generally the first step is the problem formulation. But since we already have the problem formulation, we have to do with the prediction of classification. With the prediction is our problem. So we know that yeah, our problem has already been set up for us. So don't think of it as a full-fledged project, although you can even like you are a beginner or something, and obviously suppose this is a full-fledged project, but it is not. I won't say it's a full-fledged end-to-end project. It's definitely interesting. You can learn a lot about how machine learning, pipelines work. First, we take insights into the data, then we visualize, then we clean it up, then we visualize, clean it up, design our model, design the model, design the model, we train the model, get our loss, adjust the model, then adjust by adjusting and fine tuning, right? Fine tune the model. This is what we use as a term. And we don't just say I'm adjusting model. Generally, we say I'm fine tuning a model. We fine tune it, and then probably we use it to finally get it. Right? Right? So these are a few rough steps of how we'll do it. Mm, That is mostly I've covered everything. Let me just think if I've left something. I don't feel like I've left something. Mm, Let me just think. It's been half an hour. I've explained everything. So I think we can take a 5 minute break. We'll keep. I think I'm trying to do a longer stream, so we'll keep taking 5 minute breaks after each half an hour because something with study streams and streams that we haven't already thought about very carefully in our mind. It's that I have to come up with things on the fly. I mean, streaming is not my full time thing, so I have to come up with things on the fly. And I think just like studying, we use the Pomodoro technique, right? Like 40 minutes studying and 5 minutes of gap. So I think after we've achieved like a proper milestone, so since we've achieved the proper milestone, that explanation of the topic, so we can take a 5 minute break. After that, after the break, I'll start with the data. I'll probably do the data wrangling, the data insights, the visualization, the cleanup. And it should take 40, 30 to 40 minutes, hopefully less than that. If it takes less than that, then we can go ahead and design the model, start it, start that training, and then take another break. Else we can clean it up, then design model and train, and check the loss and everything. In the second half, we do the adjustment and correction. Like we take three breaks, so it's broken down properly, and you can follow along easily. So yeah, that being said, I'm taking a 5 minute break. We got to do some check some data, and then we can start on it. Okay. Okay, let's get into some topics. Uh, okay, so initially we'll import some values for numpy, for for matplotlib, yes, definitely. That's a secret. Okay. Okay, now we need to check the data stream. Give whether let's see the following. We have degree, which is the daytime. Again, yeah. Land average temperature with uncertainty, land max temperature, uncertainty, land min temperature, uncertainty, land and ocean average temperature, land and ocean average temperature, uncertainty. So I think behind the data, there are mm, this time, and an ocean average temperature. Let's find out that. Mm, and the uncertainty columns, I think you can drop those, right? The uncertainty columns don't are not it is right. Mhm. What we have here, land average temperature. Um, mm, 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 yeah. And what are the number of total points? We have the number of total points. We have 3,191 columns. Let's see what percentage is question. One, one, that, one, total number of pounds, right? This is from here only. And now, uh, first thing, um, the column, number of column, column, um, yes, column, column, uh, each one, By total number of lines, like 59. Normal. Interesting for I will be comment. We have to return something. Let's name it null percentage. Right? It sounds better. We can name it null percentage. Null percentage. Set it to effect just okay. The column DTs for the issues, the column like like this. It work. Yes, because what happens is if we go here and we add a code column here with the info. Let's take it. Yeah, so DT is not a numeric, it's an object type, right? It's an object type. And it checks the shape also. If you check the shape, right? Yes, but you know, we could have just checked the shape. It's not that, okay. Hmm, hmm, yeah. You don't need the total number of nodes, like, uh, yeah, null percentage will not be the, null percentage will actually be the total number of total rows, right? Not total. Yeah, okay. Sure. And actually, this is not exactly needed for each. Never mind. We can just print it. We can just, we can just, see, Little. Okay. It's been a notice statements. The separator is not working. When the separator keyword works, just like this. And right. So land object temperature is good. Land object temperature and site range is also good. Land mass has too many nulls. But it's already less than 50%, right? So we can drop the null value. If it's less than 6%, we generally drop the null values. So that's the rule of thumb. So now we start with, you know, mhm, mhm, data constructing, let's call it. Let's call it, that's a call it. Data formatting, preprocessing, yes. So we return data preprocessing. Mhm. If we do is, let's put this file. Yes, it's very static. So if we check the, the maximum and minimum balance, okay, we'll do this. We have talked, yeah, let us name the variable. Thing has happened wrong. I don't know. Something changed. Yes, in place is not rendered. So TF further is already set to this. It's just this, I think this is what that. Yes, that is how it is supposed to be. Okay. Okay, so we got rid of the noise. Let's see. We have rid of noise. Delete some, we need to delete some columns, right? Delete the column. So what columns do you want to delete? Before that, data preprocessing. Let's see data visualization, right? The concept of data visualization. Mm, visualization. I'll do the basic data visualization. I'll just use mm, heat map. So correlation equal to basically correlation and estimate. We need to put predict time there. But, um, Weak correlation. This is not supposed to happen, right? Bit of weak correlation is the for the weak correlations, right? All the uncertainty columns, right? With all the uncertainty columns, we have weak correlation. Although among the uncertainty column, let me just give me a second, just take a second. Uh, Set up the mask. Okay. As you can see for the uncertainty columns, it's really pathetic. So we'll drop the uncertainty column, right? Um, it's, it's, um, it's something. Husband doesn't have control. Uncertain. Mm, which Jesus, whether that time in place and just check the columns. Yes, we've got rid of the uncertainty columns. We just do this once again. We do this once again. Check the data, visualize it, and see if it all has. See if you can see it all has a good, land max temperature and land average temperature almost has a correlation of one. Land min and land average almost has a correlation of one. Not almost it had directly has a correlation of one. These almost have a correlation of one. So we have taken the right values and we're trying to we'll take this value to predict land and ocean average temperature, right? Okay, so we have cleaned our data. Now there's one column that that text box change the column. So what we do for the gritty column is first we change it to date time. Yes, gritty. To the time to the time um, typos all around that to the time okay, so that's and then let's check it further. Yep, it has turned into daytime. Mm-hmm. 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 Yeah, it's starting from 1200 because it dropped the null values, right? So we'll make a new column called month, which will be yeah, that that would be that would be what would work. It will work. It doesn't have a month, right? It doesn't have Yes, it has a month now. It actually has a month now. No, no, no. Um, just meaning for count values, right? It is count values. So check how many values in each month because values support by set command. That's count values, right? Value counts. It's not count values, it's value counts. Value count. Yeah, we have exactly 160 data for every month of the year. That's beautifully said. I tell you that we don't have to oversample or undersample for each month. Okay. Similarly, we do this thing for. I don't think if we need year also. Hmm, Year also. Okay, let's do year also. So we have from 1850 to 2015. Okay, okay. Now we'll start with our model training. We can take a break. We'll be right back. One more Elizabeth, and then we'll start next point here will be the model training. Should we start the training? I think we should start the training, right? So we have a target column, right? We need to drop one column. Here, this the step we need to drop the. Mm, okay, not the GP. Let us just take the further for one time. Plan of a month and year. So we will not take year into consideration, I think, but month we can definitely take like okay, some more say data preprocessing will be there. Mm, so let's take the standard variation. Let's just draw a histogram of the data. Uh, destination. One, uh, we do this plot right. We do business plot. Uh, we, we, then I no, uh, no, okay, okay, and we will do that. We submit 20, 20 Yankees, and we have to speak size like size, six size, we cannot figure out. We cannot figure out the six size that is one of the standard six sizes that we use to get okay. Okay, land average temperature, land max temperature has a value like this. So you see, it's not very consistent, right? It's the minimum and maximum values keep changing. So one thing we can do is escape learning dot preprocessing. We use scaling right. Preprocessing reports, max scalar. Now we take previous I think we don't scale the whole data. Yeah, we just keep missing. Device, become the charge. So we use regression basically. We have to do processing, but first we have to do exactly what I was thinking, what I remember is first we only do processing on the feature columns, not on the target column. So let's define it into target and features. So our target column is target column is this one. And our features columns are features are uh, uh, top top columns equals to target. So drop the target column in that case is our feature columns target and also we really want this. Yes. Okay. Split it into train test set. So we split it into train test set. Test test train test split. And skeleton. Hmm. The image is also there nowadays. Dot monetization. Okay. Train test split. Train test split. Train test split. And we need to convert the train test split. Yes, yes, yes. Equal to equals like yes, 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 that equals. Oh yes, we'll not select the prediction column, or as we call it, the Y column. Let's first name its features, right? Let's just name it column. Let's name it Y column equal to the target column. The right thing just let it in Y in the text size is suppose 0.2, I mean 20% data will be kept for testing, and we keep a random state of everything, no solution to everything. Right? Okay, there's none. Okay, okay, and then we check print, explain the shape, explain the shape, and just test the shape. Hmm, I want to crop the column target. Yeah, I also want to crop the month 10-year column because they don't give us much things. And should we crop the month 10-year column? Uh, Now keeping the target like this. Later, let's just keep it for hypertuning. Uh, mm, one column. I think it will be better if we don't have the month and year, but maybe like yearly it's changing monthly also the weather changes like it goes a bit, you know. Mm, purchase, white, in the and yes, yes, and yes. Okay, 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 okay. Now it's maybe instead of scalar equal to I don't know. Is it? Can you split that training data like it's equal to scale of dot constant And from then, then for the test, we just only transform it. We don't have to pick it. X test. And then test. And now we start training our model in maximum month and we use the linear regression model, right? So we take sklearn dot linear models, so sklearn dot linear model, okay, linear regression, linear regression model, okay, linear regression, and then model dot train, I think, other model train, it's model dot data. Then what? Let it train, then we'll start with the model testing. Let's do this. Let it train and let us take a break. It has already trained. Let us just finish it. Okay. Let us just finish it. Then we take a break and then probably we do one more, one more thing. So while break, we do maybe what like that. Um, uh, This year is what we are having. Expected, it's not transformed. Yes, positively. From I think from skill learning dot so that we have we have what Actually, this or actually still a news. Still a news. So the error is very low. Like the error is very low. Some 10% error. You can also fix artist level. Especially in the system. So it fits pretty well. It's like 10% fitting. Um, Final tuning is just one, once then we have columns. Uh, let's try that. Mm, mm, Okay, removing one penny keeps us worst code, so let's keep one penny. We'll keep that here, like this. Yeah, so that's it from right now. We'll might do some other stuff, like it now. Yeah, that's it for today. Goodbye. And share this with the comment section.